Dear friends, welcome back to VK Jain Sir ki MEP classes. My dear friends, engineers, architects and students and consultant engineers, once again on fire series. This time we'll discuss fire pumps and static water storage tanks. Friends, it is very clear that the designer must provide one static tank, water tank in every site, and how much it will be is given in National Building Code. I have shown uh, one particular example of category hospital. If you are planning for hospital premises, uh, the hospital uh, category ground plus two or more story with beds. Underground tank has to be 75,000 liter, and you have to compulsorily provide a terrace tank totaling to 10,000 liter capacity. All hospitals buildings having less than 15 meter in height with plot area more than 1000 square meter, the underground tank capacity has to be 1 lakh and terrace tank capacity has to be 10,000 liters. If the hospital building is 15 meter and above but not exceeding 24-meter building in height, then the tank capacity has to be 1.5 lakhs on terrace tank 20,000. In hospital categories where the height is more than 25 meter and not exceeding 45 meter in height, the underground tank capacity has to be 2 lakh liter, whereas on static tank it has to be 20,000. To keep the campus secured against the fire round the clock, the owner or occupier has to provide an emergency water storage tank, which is known as static water storage tank. It is called static in comparison to dynamic storage being faced by fire brigade. So in case of when this tank, static water tank, get emptied, then you remember we have provided one 4 inlet connection where the fire brigade people can pump the water to this storage tank from which the firefighting system will work. Friends, I am taking one more case of business buildings. You know, business buildings are those buildings where the uh, transactions are carried out on basis of checks, not the cash. And this includes all office buildings, sale tax, income tax, and building alike. In case of business buildings less than 10 meter in height, the static water tank is not required, whereas uh, the terrace tank has to be of capacity 10,000 liters, and somewhere it could be 5,000. You have to see the note number 6 provided at the end of the mm, table. Now these notes you can always see note number 6 at the end of the table. When business building is having height more than 10 meter but not exceeding 15 meter height, it has to be 50,000. Whereas in case of buildings having heights above 15 meter and up to 24 meter in height, it has to be 1 lakh, and the water tank on terrace has to be 10,000. In case of building above 24 meter to 30 meter, the static water tank has to be 1.5 lakh liter capacity, whereas terrace tank will be 20,000. In case of business buildings more than 30 meter, the underground static water tank has to be of 2 lakh capacity, whereas on terrace it has to be 20,000. The tank should not be more than 3 meter deep. That means the depth of the tank must not exceed 3.5 meter, because then it is very difficult for cleaning personnel to get down and clean the tank, and it shall be having a slope of 1 to 100 and 1 meter deep sump of 1 into 2 meter at the lowest end. This is for taking foot valve. The slide, the side with sump should preferably be at the front and should have an easily removable manhole cover through which fire engines suction hose can be lowered into the sump for direct pumping. A static water tank should be designed and constructed in conjunction with domestic water tank wherever feasible. Dear friends, let us revise the component of an internal hydrant system. An internal hydrant installation comprises of the following elements. 1. A static or terrace tank for storing water for firefighting purpose. From this static tank, we take the water into rising mains, and from the terrace tank, we take the water into downcomer mains or external mains to feed water from source to be required point under pressure. Firefighting pump or pumps with all fitments and components and pump control panel housed in a pump house. All necessary components like internal hydrant, that is landing valves, and external hydrants provided in yard hydrants, hose reel, hoses, and branch pipe suitably housed. These are the components of a internal hydrant system. Dear friends, I am showing the schematic diagram of pump room as provided in National Building Code 2016. The the water tank can be of two configuration, one with negative section and another where the fire pump is provided below the tank. So it gets a positive section. This is the section point. This is the section point, and pump is below the tank. Now come to tank. The tank should be provided with two compartments. In both the cases, these are the two compartments, and the components of this tank are 4 number 63 mm inlet, known as fire brigade inlet, which is provided at the exterior boundary of the campus, and from where it is taken, the water is sucked in case of emergency into this tank. This tank, through a fire pump, is always kept primed. The priming means you have to keep the water all the 25 hours, 24 hours and 365 days. The tank is provided with a manhole, and since the tank is having two compartments, this is the compartment line, one compartment, second compartment. Both the compartments are provided with suction pipe connected permanently to the fire pump. The tank is provided with overflow and vent, so that uh, when the tank is full, tank is getting water supply from uh, municipal corporation, as well as in case of emergency from the fire brigade. So in both the cases, you can clearly see that a cleaning hole is provided in case of positive section, this one. And I'll show you another diagram next. Friends, this is showing the requirement of underground tank. Underground tanks should be provided with compartments with external interconnection at bottom level, having gate valves at both the ends for periodical maintenance and cleaning purpose. At least two manholes, each of adequate size, with cover conforming to Indian Standard 1726 Part 1 of year 1974, should be provided on the tank outside the pump house, so as to facilitate fire appliances to draw water from tank when necessary. Access road to the tank, where located outside the building, should be at least minimum 6 meter in width, and the same should be designed suitably to bear a load of fire appliances weighing up to 18 tons. The access roads should be kept free from encroachment and obstruction for all time. Friends, once again, the requirement of designing the pump house. The pump house should be located preferably outside the building with a minimum clearance of 6 meters from adjoining building. The pump house should have adequate natural ventilation with windows fitted with expanded metal for protection. If the pump house houses a diesel pump, the exhaust pipe of diesel engine should be extended to outside the pump house and exhaust discharge at an appropriate height in open air. The floor of the pump house should be sloped to the farthest end to drain water away any water leaking from glands and valves. The pump house should have normal lighting and also emergency lighting facilities, either from a second source or from generator. If the pump house is located inside the building, either on the floor, one or in the basement. It should be separated from rest portion with a wall of having 2 hours fire rating and fire check door at its entrance having 1 hour fire rating. For pump house basement, forced mechanical ventilation should be provided. Pump house in the floor one should be located in on periphery of building with access directly from outside or open area. This picture shows you a typical fire pump room having one diesel engine and pump and another electric electric pump and third one is jerky pump. The pump must be provided on a foundation which takes up the load of the pumping side, and this should be at least 0.3 meter from the floor. If friends, this diagram shows a diesel engine driven pump. This is a multi-stage pump with vertical split casing. In case of vertical split casing, these are the casings housing several impellers. It is multi-stage. It is known as multi-stage. There are several impellers. These are circular impellers, and they are provided with suction suction and delivery from this. And this is the coupling of pump with the diesel engine. So let us and they both the pump and the diesel engine are both provided on chassis, and below the chassis there will be springs so that the vibrations are not transferred to uh, your structure. The radiator of diesel engine is shown separately here, and it has got exhaust through a silencer pipe, and this exhaust must be above ground floor, exhausting into a proper area where it does not harm anybody else. Friends, this diagram, this slide shows a horizontal split keeping fire pump. The splitting is horizontal, and this portion can be removed so that you can see other parts of the pump properly and do the maintenance activity. Here, through bearing, it will be connected to its driver, which will be electrical motor. Now, on the right hand side, the opened up details of the horizontal split casing pump are shown. This is the shaft, and here is the space for the impeller to sit here, and the outlet, the water is sucked and outlet is there. Friends, as stated earlier, a diesel engine pump and electric motor run pump are always provided at minimum. What one more pump is provided which is known as pressurization pump or jockey pump. It may be vertical type or horizontal, and it is provided to pressurize to keep the water line primed all the 24 hours 365 days. If in the vaterizer any and yard hydrant any drop is removed beyond fire purposes, this jockey pump gets started and maintains the water supply prime in the system. This jockey pump horsepower is limited, maybe around 7.5 HP. Friends, let us discuss how a fire pump is selected. In practice, the design professional combined National Building Code 2016 capacity and pressure requirement with the detailed pump performance standard, Indian standard 12469 or Indian standard 15301 or NFPA 20 to select a fire pump whose HQ head and discharge curve meets both code mandated system demand and pump performance criteria. The CPW demands the pump to be selected as per NFPA, and the NFPA requirement is that the pump cell furnace 150% capacity at not less than 65 head. This can be seen like this. This is 150% discharge at 65% head. The, so this is the required curve, HQ curve, according to which the pump should work. The other criteria is the shut-off head shall not exceed 140% of rated head. 140%. This, if the head requirement is more than this, the pump will close. In this slide, we are discussing where the pump room should be located. Preferably, the pump house shall be located outside the building at minimum distance of 6 meters from adjoining building as per Bureau of Indian Standards. That means Indian Standard 12,469. As per NFPA, it shall be 50 meters away from the building. Say, huge difference. In case pump room is located inside the building, ground or basement, it should be separated from the rest portion with a fire wall having 2 hours rating, fire rating, and fire check door at its entrance having 1 hour fire rating. As per NFPA, the rating required shall be 2 hours. The pump room inside the building shall have direct access in form of ramp or stair. The fuel tank capacity shall be sufficient to run the diesel engine pump for minimum 4 hours as per Indian standard 12,469. As per NFPA 20, fuel supply tank shall have a capacity of at least equal to 5.07 liter per kilowatt plus 5% volume for expansion and 5% volume for sump. Now we can compare the Indian standard with respect to NFPA requirement. There is a vast difference between the two. Friends, as we know, the pumps there shall be minimum 3 pumps as per National Building Code 16, and there may be any more number of pumps. So normally we require one diesel pump, one jockey pump, one electrical pump for one waterizer, another electrical pump for yard hiding system, and one more pump for sprinkler. So we have to arrange them as per requirement given. A minimum clearance of 1 meter at front and back and 0.75 meter on sides and between pumps should be provided for all major pumps exceeding 2280 lpm capacity. For smaller pump including jockey pump, the clearance requirement should be 0.75 meter at front and back, 0.6 meter, and at sides between pumps. The headroom clearance for all pump houses should be minimum 2.75. That means the height of the pump rooms should be minimum 2.75. As per BIS, Bureau of Indian Standard 12,469, the foundation of pumps shall have minimum grade of reinforced concrete at M15. The thickness of foundation shall be 50 mm for pumps up to 900 lpm and 75 mm for pumps up to 2280 lpm, 100 mm up to 4500 lpm, and 150 mm for higher pumps. As per NFPA 20, the weight of foundation must be at least 5 times the weight of pump motor set. Foundation bolts of proper size should be embedded in the concrete to a depth of 8 inch to 12 inch and locked with either a hook around reinforced bar or by J-shaped bolt. The capacity of jockey pump shall neither be less than 3% with a minimum of 180 lpm or more than 10% of the installed pumping capacity. Friends, this is a very important diagram regarding capacity of underground static tank and the fire pumps. Now let us first take underground fire water tank capacity, which here for example we have taken 1 lakh liter, but we have already shown elsewhere that the requirement may be from 50,000 up to 2.5 lakhs liter. The underground static water tank is provided with a 150 mm diameter 4-way fire brigade connection through which the water is sent to this underground tank when its capacity is over. Normally, uh, we have water supply source, one from 50 diameter inlet from municipal corporation, and another inlet from the tube well should be provided. This fire tank is provided with a grout connection of 100 diameter. These are the minimum requirements, and you must remember that the underground tank has to be kept full all the times with its rated capacity for all 365 days and 24 hours. This underground tank, the water from this underground tank is taken through a combination of different type of pumping systems, at least three. There has to be a diesel engine and pump. There has to be a electrical motor and pump. There has to be a jockey pump which maintains the pressure in the entire water circuit. Now, these pumps are required to work in parallel through two header connection at both the end, at this section end 200 diameter, and at the delivery end once again 200 diameter. From this system, we have we are required to take one connection to fire hydrant ringman, that is known as yard hydrant system. Then there is another which is feeding to fertilizer system, and there can be third connection, but in that case one more pump has to be added for the water spray system, vertical water spray system. Friends, this is the schematic diagram of pumping set working in parallel, and the legend provides what is what. HP is hydrant pump, main electric pump. JP is jockey pump or pressurization pump. DP is diesel pump. They are shown here. Then SH is suction header and DH is discharge header. ST shows strainer, and different type of pumps have been shown here along with their valves. The three type of valves are here, and the pumping arrangement has to be made accordingly. Friends, this is the last uh, diagram which shows the layout of pumping system, pump room, both in plan and elevation. Elevation wise, you can see that you have to come down if it is in basement through these stairs. When you This is a ramp for coming down, or they can you can provide the steps also. Now there are this shows five number of pumps. One is jockey pump. This is diesel pump. This is electrical pump, and likewise. So maximum 5 number pumps may be required, and this gives the clearance. The pump room size should be 12 meter by 6 meter. These two pumps, SP, is known as sprinkler pump. So thanks for listening me and judging the fire pump system.